In mechanics, how many chapters? 4. First chapter. अरे था क्या पहले चैप्टर में? क्या था पहले चैप्टर में? हाँ, कार्ड के उसके अंदर कितने सब चैप्टर्स थे? 7 थे. दूसरा चैप्टर क्या था? सिस्टम. तीसरा क्या था? मैकेनिक्स ऑफ कंटिन्यूअस मीडिया. चौथा क्या है? स्पेशल थ्योरी ऑफ रिलेटिविटी. Special theory of relativity was propounded by Einstein in the year 1905, and there is another theory of relativity which was developed by Einstein in 1915. The theory which was developed in 1915 is called general theory of relativity. General theory of relativity deals with accelerated frames. Our earth itself is an accelerated frame with respect to sun. Correct. So for gravitational motions, we deal with GTR, general theory of relativity, which deals with what kind of frames? Accelerated frames. We are not concerned in special theory of relativity. All frames are dealing with only inertial frames. What is the essential requirement? All frames are inertial. Who are inertial frames? Either at rest or moving with uniform velocity. So throughout the entire course, all 4 classes, I need not repeat. If I am saying an observer is traveling with velocity v, then velocity has to be constant. dv by dt has to be 0. That is understood. Special theory of relativity. In the syllabus only STR is there. GTR is taught as a special paper in master's classes. General theory of relativity is not in the part of any course. It is taught in the master's as a special paper, not in the main curriculum. So nothing to do with GTR. You have to deal with only special theory of relativity. The first point is understanding the syllabus, because this is taught in BSc first year and this is taught in BSc third year. This course is whatever taught in advanced classes. So right opposite is not the Lorentz transform and its consequences alone. That is the first thing. There are 4 chapters, 4 subtopics within the unit 4. 4.1 Lorentz transforms and its consequences or its applications, whatever you want to say. 4.1. There are 7 such applications. 1, 2, 3. How many? 7. Lorentz transforms and its applications or consequences. What are its consequences? Length contraction, time dilation, simultaneity, velocity addition theorem, Doppler effect, स्टेलर एबेरेशन एंड डेंसिटी. 7 हो गए. लेंथ कॉन्ट्रैक्शन 8वां टॉपिक नहीं है. लेंथ कॉन्ट्रैक्शन, टाइम डायलेशन, साइमल्टेनिटी, वेलोसिटी एडिशन थ्योरम, डॉपलर इफेक्ट, स्टेलर एबेरेशन एंड लास्ट डेंसिटी ट्रांसफॉर्म. समझ में आ गया? ये क्या कहा मैंने? 4.1 लॉरेंस ट्रांसफॉर्म एंड इट्स एप्लीकेशंस और कॉन्सिक्वेंसेस. दैट इज द फर्स्ट. इसके अंदर भी 7 छोटे छोटे टॉपिक हैं. यही बीएससी फर्स्ट ईयर में यही पढ़ाते हैं पहली क्लास में, यही है. उसमें भी 3-4 ही पढ़ाते हैं बस. 4.2 मास एनर्जी इक्विवेलेंस. मास एनर्जी इक्विवेलेंस. मास एनर्जी इक्विवेलेंस. मोमेंटम एनर्जी. मोमेंटम एनर्जी ट्रांसफॉर्म्स. Momentum energy transforms 4 vectors. Concept of 4 vectors. Momentum 4 vector. Momentum 4 vector. इसी में समझ लो मिन्कोवस्की स्पेस. And 4.4 is covariance. Covariance of equations in physics. एप्लीकेशन टू द डीके प्रोसेस, आराम से पूरा यूनिट पढ़िए, देखिए सिलेबस खत्म हो गया। एप्लीकेशन टू डीके प्रोसेस, इसको पढ़ाने में 2-1.5 दिन लगेगा, ये आधा दिन का है, 2 दिन खत्म होगा, 1 दिन 4 दिन, इस तरीके से खत्म होगा, थर्सडे तक खत्म हो जाएगा। पढ़िए जी सिलेबस पढ़िए, पूरे देखो खत्म हो गया सब कुछ, वट एवर इज रिटन। 2 questions are asked minimum. How many? 2. Every year there must be 2 bits from this chapter. 2 bits. Read the syllabus, पढ़िए, आप भी पढ़िए। माइकलसन मोरली एक्सपेरिमेंट, ठीक जी। लॉरेंस ट्रांसफॉर्म्स, लेंथ कॉन्ट्रैक्शन, टाइम डायलेशन, वेलोसिटी रिलेशन थ्योरम, एबरेशन एंड डॉपलर इफेक्ट, मास एनर्जी रिलेशनशिप, सिंपल एप्लीकेशन टू द डीके प्रोसेस लिख दिया। देखिए 4 डायमेंशनल वेक्टर, देखो लिख दिया, मोमेंटम 4 वेक्टर, कोवेरियंस इक्वेशन लिख दिया, फिनिश्ड। यही है, ये तीनों एडवांस टॉपिक्स हैं, ये दोनों जो हैं एडवांस टॉपिक्स हैं। इन 1887 माइकलसन एंड मोरली performed a famous experiment. They fabricated a device called interferometer. Michelson-Morley interferometer. Interferometer is a measuring device. Any meter and scope. Spectrometer, spectroscope. Scope is to view. Anything I want to view, it is scope. Whenever I utilize that viewing for measurement of some physical parameters, I call it meter. So interferometer is a device based on interference of light to measure something. So Michelson-Morley devised an interferometer, and by the help of that interferometer, before that, it was which year? 1887. Even at that time, even 1 meter length was not standardized. What is 1 meter length? That was also not standard. Variable things were there. So by the help of this, and velocity of light was not absolute constant. The way we understand these days that velocity of light is an absolute constant. It is same for all inertial frames. Everybody has got that notion that velocity of light in free space, that is 3 into 10 raised to power 8, does not depend upon frame of reference. In every frame it is same. This was not the time when this was thought that velocity of light is same in all frames. Good. So if like 2 bodies are traveling relative to each other with velocity v1 and v2, the relative velocity will be v1 difference v2. Correct? So similarly, if something was some device was traveling and light was emitted by that device, then velocity of light relative to the device could have been, if it is in the same direction, c minus v, opposite directions c plus v, because c at that time was not thought to be absolute constant. Correct? If light, some device, interferometer is moved by distance v, and at that time it was also thought that whole world, because for propagation of waves, it was thought that always medium is essential. There was no concept of electromagnetic wave that do not require any medium to propagate. Every medium, mechanical waves, requires medium for propagation. So how light will propagate? Light was propagated, that it was thought that in the space there is an hypothetical medium called ether. Ether is present. So whenever I say device is moving by velocity v, that is device is moving by velocity v with respect to ether. Light is traveling by velocity c, then light is also traveling by velocity c with respect to ether. Good. So relative velocity of light, because an instrument was there, this Michelson interferometer, it was moving by velocity v and it was emitting light. So velocity of light with respect to the device must have been c minus v, going in the same direction. It was a mirror at the other end. So how much time it would have taken? L upon c minus v in going. Coming back, L upon c plus v. So total time taken before interference from the device, light signal was going. From the other end, there was a mirror. From that mirror, that device light was reflected back. and this light was fed to interferometer, which was causing the fringe shift, correct? So if this was there, that C minus V and C plus V were existing, then there must have been a path difference, and path difference would have given rise to a phase difference. There must have been a phase shift in the device, Michelson interferometer, if C minus V and C plus V was there, relative velocity we were able to write like that. But experimental detection was that no fringe shift was observed. No fringe shift was observed in the device. So this, many people interpreted this results in different ways. That ether was dragged along with the whole device. So there was nothing called C minus V and C plus V. Then another explanation came from the Fitzgerald, that he said to explain the no fringe shift. First of all, when no fringe shift was observed, fringe shift would have been observed if C minus V and C plus V, that time taken would have been obtained from C minus V and C plus V, L upon C minus V plus L upon C plus V, and vertically then 2L upon root C square minus, if they would have been T1 and T2 would have been different, they were different. There was a time difference between both the waves coming from, directly reflected from the mirror, and another mirror which was put perpendicular to that. There was a fringe shift, no fringe shift was observed. No fringe shift was observed is called null results of Michelson-Morley experiment, correct? No fringe shift was observed, it is called null results, correct? So how these null results were interpreted? There were three different interpretations of this. One was ether drag hypothesis, that ether was dragged along with the device. When ether was dragged along with the device, relative motion with respect to ether didn't have any meaning. Second explanation was given by Fitzgerald. Fitzgerald said that along the direction of motion of the device, length is contracted by factor of root 1 minus V square by C square. That is how he explained that there was no time shift, no time difference, there was no fringe shift, no path difference, so no fringe shift. That was explained by Fitzgerald by saying that along the direction of motion, that direction in which device is being moved, length is contracted. Length doesn't remain same, length is contracted by the factor. This didn't have any logical explanation, but randomly, intuitively, Fitzgerald explained that. Good. But none of these explanations were widely accepted into the world of physics. Neither ether drag hypothesis, that also had many flaws, nor your Fitzgerald. But Fitzgerald's hypothesis couldn't be denied at that time because he had randomly said from where that factor had come, there was no logical explanation that why it is reduced by the factor of root 1 minus V square by C square, why not by some other factor. He didn't have any logical proof or derivation for that statement. But it couldn't be denied, neither it was accepted. Then came Einstein. Einstein propounded that velocity of light is absolute constant, it is same in all frame of references, and there is nothing called C minus V or C plus V, and concept of ether is an absurd idea, there is nothing called ether. So the concept of ether was denied, and velocity of light in all inertial frames remains constant, and it is absolute value C, 3 into 10 raised to power 8. That is the starting point of special theory of relativity. So now then, from 1905 onwards, we assume that velocity of light, experimentally verified, that velocity of light remains the same in all inertial frames. If some quantity, some physical parameter remains same in all inertial frames, it is also called invariant. Good. So velocity of light in free space or vacuum remains invariant. That is the second postulate of special theory of relativity. So this postulate came as a consequence of null results being observed in Michelson's Morley experiment. Correct? This is the historical background of this. Nothing more, no derivation, nothing I can talk right now, because for this you need to know the complete background of Michelson's interferometer and concept of interference. So I am not going to teach, only historical background was required. Why, how do we arrive at the postulates of special theory of relativity? So special theory of relativity had two postulates. Postulates of STR. Second postulate is velocity of light in free space or vacuum. Vacuum or free space is invariant in all inertial frames. This meaning is clear. This postulate was a consequence of your null results of Michelson. Second is all laws of physics in all inertial frames are of the same form. All physical laws in inertial frames are of same form. All physical laws are of same form in all inertial frames. Correct? All fundamental laws are of the same form. This also I can say. What I can say? Every physical law is invariant to all inertial frames. Every physical law remains invariant to all inertial frames. Physical laws are invariant. Invariant means they are of the same form. They do not change their form. Are invariant in all inertial frames. They are the two postulates of a special theory of relativity which were propounded by Einstein to explain the results of Michelson-Morley experiment. समझ में आ गया भाई साहब? अब देखिए, by the help of these two, we will arrive at the coordinates of an event. The very same way we were seeing the transformation from left frame to center of mass frame, that is inertial frame to inertial frame. We have seen transformation from inertial frame to non-inertial frame, rotating frame of reference. Both these situations, velocities were very less compared to velocity of light. Now, if the velocities are comparable with velocity of light, subatomic particles are involved, or velocities are comparable with velocity of light, then how this transformation from one inertial frame to other inertial frame? I am only changing from one inertial frame to other inertial frame. Event in physics is space and time. Event in physics is specifying space and time. Space means R and T. R means in Cartesian coordinates, if I have to X, Y, Z, T. This may be the coordinate of an event in frame S. In frame S dash, which may be another inertial frame travelling by velocity v with respect to S, t is equal to 0. Both the frames may be coinciding. T is equal to 0, both the frames must be coinciding. Now that frame, that observer starts moving by constant velocity v, that frame is called S dash frame, another inertial frame. In that inertial frame, coordinates of an event may be x dash, y dash, z dash, t dash. Correct? So how I will write these transforms? What are they? Write W set. If I say this is observer O, this frame is S, this is x, y, z, t is equal to 0, another observer O dash was here. Now this observer O dash and starts moving, or I say this observer starts moving by velocity v towards x axis. This observer is O dash. At t is equal to 0, both the frames were coinciding. Now this observer starts moving by velocity v towards only x axis. Whatever x is, observer is moving, that I am calling x axis. Good? Only one direction is moving towards this. V is a constant, I did not tell. Special theory of relativity, frame of references are all inertial. That means dv by dt is 0. An event takes place here. O says, observer O measures the coordinates of an event as x, y, z, t. Observer O measures the coordinates of an event as x, y, z, t. That means this distance is your x, this would have been your y, that would have been your z. Same, if the same event is measured by O dash, if O dash measures, O dash is a moving observer with respect to s by velocity v, inertial, v is constant. He says that his coordinates are x dash, y dash, z dash, t dash. Okay. What do you expect of y and y dash? Same. No motion is along y axis, no motion is along z axis. So y dash will be y, z dash will be z. Motion is considered only along x axis. So what are the typical transformation? देखिए, y dash is y, z dash is z. What is x dash? How x dash and x are connected? Why that is? What is the difference between both of them? X minus x dash. X minus x dash must be equal to what? Vt. Correct? That means x minus x dash is Vt. That means x dash is x minus Vt. That is what you would have expected. It is traveling by velocity v in time t dash is here. Good. Time in both the frames must be same. Time they, both of them must be regarded as the same time. T dash is t. Good. These things are known much before Einstein. They are the normal thing, normal understanding. This normal understanding is called Galilean transforms. What are they called? Galilean. These are known since 14th century, 15th century. How I would have written? Time is same in both the frames. Time is not different. Some event takes place here. Both the observers say it is at 10 o'clock or 11 o'clock, whatever. Time is same in both the frame of references. These transformations, they are the fundamental laws of transformation from one frame. This side is frame S, this side is frame S dash. If I would have measured this, I would have easily written from this transform towards this thing. These are called your Galilean transforms. Okay? Nothing, no relativity I brought into. For bringing relativity, what is important? That velocity must be compared with velocity of light. Now I am making the relativistic. These are known. This is known. What are the first postulate? All physical laws retain their forms. They are of invariant. This is the physical law. How I am changing coordinate of an event from frame S to frame S dash? These are the transforms. Some modification in these transforms only have to make. Modification means some correction factor. Dimensionally x है, Vt भी वही है, y dash भी वही है, सब dimensionally correct है. So मैं जो भी correction लगाऊंगा, correction factor must be some factor which will be dimensionless. क्या? Correction factor यहाँ alpha लगा दूँ, beta लगा दूँ, gamma लगा दूँ. If I say velocity may be compared with velocity of light and I want to utilize the postulates of a special theory of relativity, first of all somewhere I will bring the light. Event is light. Good. So what event I will say? Some star is traveling, let us say. Yes, this frame is traveling and it is torch. Event is light flash. What is event? Light flash. This is torch or star emitting light. Star is moving by velocity v with respect to this is inertial observer. Star is moving by velocity v and it is sending light. Here it is, whatever the event is throwing up the light. Correct? ये पहले से मालूम है कि नहीं ट्रांसफॉर्म? First postulate is every law should retain its form. So I have to retain these forms. But now because I have to see that velocity is compared with velocity of light, I am changing that event is the light flash. Here light flash is lit. So what will happen? If the light signal is there, all inertial frames for observer O dash as well as for observer O, light will be traveling by the same velocity. Good. So try to appreciate. This is the path by which light will travel. What is this distance? R dash. Same thing is called R dash. X dash, Y dash, Z dash, R dash. Correct. What would have been R dash? C into T dash. क्या? C into T dash. Time in this frame is T dash, correct? What will be in this frame? Light signal reaches to the O. How much time light will take here? How much distance light will travel to reach here? CT. Try to understand one important point. If T dash is T, first of all, do you agree that both the distances are different? This distance, x dash square plus y dash square plus z dash square, correct? That is r dash square. बताइए भैया r dash क्या है? This is 0, 0, 0. This is x dash, y dash, z dash. Then r dash is x dash square plus y dash square plus z. And what is r square? X square plus y square plus z square. Both the x dash is not same as x. X dash is not same as x. So therefore r is also not same as r dash. If velocity of light is same in both the frames, velocity of light is same in both the frames, then t dash must be different from t. Otherwise ये दोनों सेम हो जाएंगे. सेम है नहीं. समझ में आया पहली बात कि I am utilizing, try to appreciate how I am utilizing the postulate of special theory of relativity to build up something new. When velocities are compared with velocity of light, these transform will be retained. I will retain these forms because form of transformation will not undergo a change. That is the first postulate. Second postulate is velocity of light is absolute constant. So I have said that this signal is a flashing of light signal. So this is C I am considering. In that frame also I am considering C. Only correction I am making that T dash is not same as T. Correct? T dash in the relativity, if velocities are compared to velocity of light, then time in both the frames must not be same. So time को कैसे correct करेंगे देखो. Time में correction factor लगाया मैंने beta some dimensionless quantity. Y time is changing due to x. Y time is changing due to x. So I am calling plus some gamma into x. Gamma may be 1 upon velocity. Gamma dimensionally will turn out to be 1 upon velocity, so that dimensions are retained. Beta and gamma are the correction factors. Good, same transform. T dash is not same as t. So for correcting purpose, I have written beta t plus gamma x, because if time is different, y time is different. Y time is different because x dash is not same as x. So I have put the correction. देखिए भैया, try to appreciate what I am doing. This is called Lorentz transforms. Lorentz transforms. Try to appreciate what is Lorentz transform. This is S, O, S dash, signal, CT dash, CT. This was your R dash, this is R. Transformation X dash is X minus VT, Y dash is Y, Z dash is Z, T dash is beta S. ये ठीक है जी. देखो, there is no change in Y dash because motion is only along X axis. So there is not, should not be, here also there should not be any change in Y, there should not be any change in Z. They must remain. Now X, there must be some difference in X also. When time is changing, time is dependent upon X. X dash may not be exactly X minus, form is same. But I am correcting some correction factor. Correction factor is alpha. Alpha is a correction factor. Form is retained. Try to appreciate. Form of transformation, these are Galilean transforms. Same transformation I have retained. Velocity of light I am making the absolute constant. R is equal to Ct. Correct? That is R square minus C square T square is 0. That means X square plus Y square plus Z square minus C square T square is 0. This is in frame S. Same thing in frame S dash क्या हो गई? R dash, CT dash. I am using the second postulate. This was flashing of light signal. So R dash square is C square, T dash square. What is this? X dash square plus Y dash square plus Z dash square minus C square T dash square is 0. I have used both the postulates. First postulate I have used while formulating this. Same transforms. Same standard transforms, Galilean transforms. I have put a correction factor alpha. correction factor beta and correction factor gamma. Good. I will find them out. So what is Lorentz transforms? What I am doing? What is Lorentz transforms? Writing a coordinate of an event from one inertial frame to other inertial frame. What is Lorentz transforms? Expressing coordinates of an event from one inertial frame to other inertial frame using postulates of special theory of relativity. How both the postulates have been used, it must be clear to you. And main thing is, second postulate is this, that velocity of light is same in both the frames, Ct and Ct dash I have written. This was one. Dekho, this is also 0, this is also 0. So I could have easily written, first equation is this, x square plus y square plus z square minus c square t square is 0, which is r is equal to Ct. It is same as x dash square plus y dash square plus z dash square minus c square t dash square. Correct? This is the main equation. Velocity of light is same in the frame of reference if this is written. Try to understand and appreciate. इसको समझने की कोशिश कीजिए. First thing, this is a consequence of utilizing the postulate of special theory of relativity. Coordinate of an event in frame S was x, y, z, t. Coordinate of an event in frame S dash was x dash, y dash, z dash, t dash. Identity is this. If I change all these variables in frame S dash, in frame S this value is 0. R was Ct. In frame S this value is 0. If I replace these coordinates in other inertial frame and this value remains 0, then I say it is invariant. This identity is invariant. So this physical identity is invariant. The way it is written, it is invariant in both the inertial frames. First concept, that every physical law is invariant. This identity is invariant. This, because this was in frame S, I replace x by x dash, y by y dash, z by z dash, t by t dash. It is also 0. This identity is invariant. Good. So by the help of this identity, which is the consequence of postulate 2, by postulate 1, I am going to replace other things. And then I have to find out alpha, beta, gamma. We have to find out alpha, beta, gamma. The resulting transforms will be called Lorentz transforms. Good. देखिए भैया, x dash was alpha, x minus vt, y dash is y, z dash is z, t को बना बीटा टी प्लस गामा एक लीनियर ट्रांसफॉर्म ले लिया. देखिए y डैश और इनमें तो दिमाग नहीं लगाना, खत्म हो गया. सो बेसिकली दिस इज नथिंग. x स्क्वायर माइनस सी स्क्वायर टी स्क्वायर इज 0 इज x डैश स्क्वायर माइनस सी स्क्वायर टी डैश स्क्वायर 0. करेक्ट. y was y dash, z was z dash. It is. Start from right hand side. Start from right hand side. x square minus c square t square is 0. Correct. Is equal to x dash square. What is x dash? Alpha square x minus vt whole square. लिख दिया भैया. x dash square are substituted. x this minus c square t dash square beta t plus gamma x. I am just opening. Beta square t square plus gamma square x square plus 2 beta gamma xt. Correct. Correct. Just open this side also. There are 3 unknowns. Alpha, beta, gamma are 3 unknowns. I should have 3 equations to determine them uniquely. Correct? देखिए 3 लिखी हुई हैं. Here it is x square minus c square t square. This was alpha square. This is x square plus v square t square minus 2v xt minus c square beta square t square plus gamma square x square plus 2 beta gamma xt. Let us see. Now I am writing x square. What is the coefficient of x square? देखिए पहले. x square I am writing. x square के साथ क्या है? alpha square minus c square gamma square. Correct. This side coefficient of x square is this. Alpha square minus c square. What is the coefficient this side of x square? 1. Both the identities are same. Then minus t square. Minus t square. What is with t square here? First minus alpha square v, if I am taking minus t square common, minus alpha square v square, this also I have taken care of, this also I have taken care, plus beta square c square, correct? This side the coefficient is c square minus c square, this side is this alpha square v square, then 2xt, what is 2xt? Minus alpha square v, 2xt common ले लिया, what is the coefficient here? Minus alpha square v, what is the coefficient of 2xt this side? Minus beta gamma c square. अरे इधर देखिए क्या 2xt कॉमन ले लिया, then what is this? Minus beta gamma c square, connect? Both the identities are same. Equate the coefficients. Equate the coefficient. I have got three equations. क्या है जी? First equation is alpha square minus c square gamma square is 1. ठीक है जी? Alpha square minus c square gamma square is 1. C is known to you. What are unknowns here? Alpha and gamma. One equation has been written. Now next, here it is the minus t square, coefficient is c square. So it is minus alpha square v square plus alpha square v square plus beta c square. Beta square is what? C square. That is second. This is the second. This is a relationship between alpha and beta. This is a second relationship between alpha and beta. First relationship between alpha and gamma. Now third, what is the coefficient of xt this side? 0. What is the coefficient of xt this side? Minus alpha square v. So I would have very well written alpha square v plus beta gamma c square is 0. Correct? Three equations in three unknowns. Three equations in three unknowns. Solve. Solve. By the help of the third one, you eliminate any one of these things. You can get beta from the third equation, substitute beta into this. Second equation is between alpha and beta, or substitute gamma from any one of them. Eliminate gamma from the third one. Get gamma from the third equation, substitute. भैया अगर solve नहीं कर सकते तो मैं कुछ क्या है? Three equations in three variables. Unique solution will be there. Only unique value of alpha, beta and gamma. Solve and tell me what are the values. तीसरे वाले से गामा निकाल के पहले वाले में डाल दो. First equation will also become alpha and beta. And mathematics is secondary and tertiary. One must know how to solve. But I am directly going to quote. हर एक को solve करना आना चाहिए. But I will directly going to quote. What is the values of alpha, beta, gamma? हो गया क्या? आ गया क्या आपका? नहीं आया? डाल के देख लो जो मैंने दिए हैं, दे सेटिस्फाइज ऑल द 3 इक्वेशंस। करो, किसी और का तो आए। ये कह रहे इनका आ गया। भाई साहब आपका आ गया क्या ब्लू शर्ट? आपका आया? तो इनका आ गया, जरा चेक कर लो इनका कैसे आ गया। इनकी कॉपी को चेक करो, इनका आ गया कि ऐसे ही आ गया? थ्री इक्वेशंस इन 3 अननोन्स, यूनिक सोल्यूशन होना चाहिए। आ गया इनका? तो आप भी देख लो, आप भी कर लो अगर उनका आ गया तो। आएगा ये जो मैंने लिखा है, और ये सही है। यही आया, कुछ और आया? 1/√1 - v² बाई c²। बीटा इज अल्फा, गामा इज v/c² बीटा माइनस v/c² बीटा। और अगर कोई डाउट हो तो डाल के देख लो, दे सेटिस्फाई दिस इक्वेशन। माइनस नहीं है उस पर, माइनस नहीं है, प्लस है। माइनस होगा, चेक करके देखो, फिर तो गलत है। अगर माइनस थे तो माइनस ही होना चाहिए। चेक करके देख लो। दे पुट द वैल्यू ऑफ अल्फा एंड बीटा इन दिस इक्वेशन, दे शुड सेटिस्फाई। अल्फा इज इक्वल टू बीटा, यहां देखो डाल दिया मैंने, अल्फा² माइनस c² गामा², that will same value will be getting. घर में जाके चेक कर लीजिएगा जाके, कि जाके डाल के देख लो। दे आर सेटिस्फाइंग ऑल द इक्वेशंस। 1/√1 - v²/c², बीटा इज इक्वल टू अल्फा, बोथ ऑफ देम आर सेम, गामा इज माइनस v/c² बीटा। डाल के चेक करके देख लो, ऑल द इक्वेशन सेटिस्फाइड बाय दीज वैल्यूज। एवरीबडी मस्ट नो हाउ टू सॉल्व दीज इक्वेशंस, बट करना नहीं है, नॉट टू बी। In the exam you can skip this maths. I expect that everybody must know. देखिए मैं सेटिस्फाई करा देता हूँ। आई कैन जस्ट वेरीफाई विद इन फ्रैक्शन ऑफ सेकंड्स, आई कैन वेरीफाई दैट दे आर करेक्ट रिजल्ट्स। अल्फा² माइनस c² गामा², गामा² इज v² अपॉन c4, बीटा इज सेम एज अल्फा, बीटा इज सेम एज अल्फा, ये हो गया जी लेफ्ट हैंड साइड ऑफ दिस. व्हाट इज द वैल्यू? अल्फा स्क्वायर 1 माइनस वी स्क्वायर बाई सी स्क्वायर. अल्फा स्क्वायर क्या है? 1 बाई 1 माइनस वी. 1 हो गया कि नहीं हो गया? अल्फा स्क्वायर माइनस सी स्क्वायर गामा स्क्वायर इज 1. आई पुट अल्फा स्क्वायर माइनस गामा इज वी स्क्वायर अपॉन सी फॉर बीटा इज अल्फा. अल्फा स्क्वायर डाल दिया. अल्फा स्क्वायर 1 माइनस वी स्क्वायर बाई सी स्क्वायर कैंसिल्स आउट. इट इज 1. सेटिस्फाइड. सेटिस्फाइड. ऐसे आखिरी वाला देख लीजिए. अल्फा स्क्वायर वी प्लस बीटा गामा सी स्क्वायर. अल्फा स्क्वायर अभी लिख देते हैं वी प्लस बीटा, लेट इट बी बीटा. बीटा इज सेम एज अल्फा. अल्फा गामा, गामा इज माइनस वी बाई सी स्क्वायर अल्फा इंटू सी स्क्वायर. फिनिश्ड. दिस अल्फा स्क्वायर वी माइनस वी देखो जीरो हो गया. सेटिस्फाइड. तीनों डाल के देख लीजिए. दिस डेटा सेटिस्फाइड. नथिंग. अल्फा इज इक्वल टू बीटा is equal to 1 by root 1 minus v square by c square. Gamma was your what gamma minus v by c square beta. They are the results. What are the transform turns out to be? Solving we get. करके जाके घर में देख लीजिए. सबको सॉल्व करना आना चाहिए. Solving we get. सीधे लिखना है. What is x dash turns out to be? What was x dash? X dash was alpha into x minus vt. X dash is x minus vt upon root 1 minus v square by c square. Look, alpha is a dimensionless constant. What is alpha? Dimensionless constant. If v is less than c, very very less than c, anything below 10 raised to power 6 I can say very very less than c, क्योंकि v square will become 10 raised to power 12 and c square is already 10 raised to power 16. So 10 raised to power minus 4 and नीचे हो गया 9. So that is also 10 raised to power your minus 5, negligible. 1 minus 10 raised to power minus 5 is negligible. So if v is very very less than c, alpha turns out to be alpha is equal to beta is equal to what? 1. This is the factor 1 upon root 1 minus v square by c square. If v is very very and what for very very less than? What velocity I am calling very very less than? 10 raised to power 6. डाल लीजिए v square by c square 10 raised to power 12 divided by 10 raised to power 16 or the order of 10 raised to power minus 4, and 1 minus 10 raised to power minus 4 is as good as 1. So if v is very very less than c, and very very less than also 10 raised to power 6. So forget about the velocities which are less than 10 raised to power 6. This is irrelevant. This term will always reduce to 1. That means it is simple Galilean transform. If v is very very less than c, x dash becomes x minus vt, Galilean transform. Y dash is y, z dash is z. So y dash is y, z dash is z. What is t dash? Beta t. Beta t. Beta is same as alpha. Alpha t. Good. Alpha t plus gamma x. What is gamma? What is gamma? Minus v by c square x into beta. Beta is same as alpha. Look, alpha is dimensionless. Vx by c square. V by c is dimensionless. X by c is time. So dimensional it is that of time. Alpha is a correction vector. They are Lorentz transforms. These are called Lorentz transforms. I have gone from one inertial frame to other inertial frame. V was comparable with velocity of light. This will be significant only when 1 by root 1 minus v square by c square is non-negligible. If 1 minus v square by c square is 1, it is same as the earlier relativity or Galilean relativity. So I am just rewriting x dash x minus vt upon root 1 minus v square by c square, y dash is y, z dash is z, t dash is t minus vx by c square upon root 1 minus v square by c square. They are called Lorentz transforms. Good. What we have done, we knew the coordinates of the event were measured by O. Who has measured the coordinates of an event? observer O, who was in lab frame, inertial frame, yes, he has measured the coordinates x, y, z and t. I am going to write down the coordinates in frame s dash, which I am calling x dash, y dash, z dash, t dash. Only difference is all forms are same as the Galilean transform. Correction factor is 1 by root 1 minus v square by c square. If v is less than c, very less than c, then x dash is x minus vt, t dash is also t. Try to appreciate. If v is very less than c, denominator is 1 and v by c square is 0. If v by c is small, v by c square will become further small. I can neglect, t dash will become simply t. So if v is very less than c, then they reduce to x dash is x minus vt, y dash is y, z dash is z, t dash is t. Good. So who is more correct? They are more correct. Lorentz transforms are more correct because they are valid even when the velocity is comparable with velocity of light. Then time in both the frames are not same. Time differs. That is why intervals here, whenever I will say two events are separated in space or in time, and space and time are interrelated. This concept is time is interrelated to the space, and space time form a continuum. We will explain in due course of time. This is called Lorentz transforms. Now I do reverse. If the coordinates of an event are measured by O dash, there is a moving observer measures the coordinates of an event, and what he will measure? X dash, y dash, z dash, t dash. Both the frames are inertial frames. These transformations should work both ways. They are from one inertial frame to other inertial frame. Now try to appreciate. Relativity works both ways. I am explaining relativity works both ways. This is S dash. S dash is moving with respect to S by velocity v. Good. Now if S dash is measuring, I want to write in frame S, then what are known to you? X dash, y dash, z dash, t dash are known to you. They are known. This is a moving observer. With respect to S, it is a moving observer, correct? But in its own frame, you are sitting in an aeroplane. How do you feel? Do you feel that you are flying? You are at rest. You are sitting in a train, car. You feel that you are stationary. So when the measurement are done with respect to O dash, this is a proper frame. All measurements are, so here the observer is at rest. How I will make it rest? Impose the velocity minus v. इस पे माइनस v कर दो. इसका मतलब ये भी होगा. So that means simply nothing. S with respect to S dash is moving by velocity minus v. This itself, as देखो, we said it was traveling with respect. I have imposed the velocity minus. This becomes rest 0. But the other frame is moving by velocity minus v with respect to S dash. Correct. Now this frame behaves like a stationary frame. Other frame is moving by velocity minus v. So this is S. Now this becomes my S. This becomes your S dash. Same formula will work. They are called inverse Lorentz transforms. Inverse Lorentz transforms. Now I am writing x. Factor 1 by root 1 minus v square by c square. Even when I replace v by minus v, then also the factor remains same. ये factor जो alpha is equal to beta is, this will remain same. Minus v whole square is also v square by c square. Now what? X was, now x dash, x minus vt. So it will be x dash plus vt dash upon root 1 minus v square by c square. Only v I have replaced by minus v. Y is y dash, z is z dash, t is your t dash plus vx dash by c square. ठीक है ना? Upon root 1 minus v square by c square. They are called, what are they called? Inverse Lorentz transforms. And I have demonstrated that V is very, very less than C, all of them reduced to Galilean transforms. Lorentz transform, clear what is Lorentz transform? By utilizing postulate of special theory of relativity, if I want to express coordinates of event in from one frame to other frame, they are Lorentz transform. I said what is invariant? I said x square plus y square plus z square minus c square t square is invariant. Good? If I say if this quantity is invariant, what do I mean by this invariance? It is invariant. Invariant means any other frame, whatever way it could be. Coordinates of an event will be x dash, y dash, z dash, t dash in other frame, primed frame. If this identity retains its form in both the frames, then I say it is invariant. Correct? Very general invariance. Lorentz invariant. Now next word I am using, try to understand invariance. Invariance is a proper concept. And this invariance only I am going to express in terms of covariance. Mathematically, they are coordinate transformation from one frame to other frame. Coordinate transformation is called tensor. And I am going to express this invariance, mathematically invariance. Invariance means this. If another frame I write, if it is of the same form, there is invariant. This invariance in physics or in mathematics will be explained as a covariance. If it will be expressed into the format of covariance. Covariance is nothing. Mathematical expression of invariance of some law or some identity. Correct? Invariance. समझ में आ गया invariance? Inertial frame yes, to other frame yes dash. It was 0, it is also 0. I say it remains invariant. Correct? Invariant is a broader concept. Equivalent of invariance is, mathematical description of invariance is covariance, which I will explain in due course of time. Now I am explaining what is Lorentz invariant. Try to understand, both the things are different. Lorentz invariant. This is definitely invariance. Invariance of some law or identity. But using Lorentz postulates, using Lorentz transforms, if any identity or any form retain its form, any identity or any law retains its form using Lorentz transformations, then it is called Lorentz invariant. Correct? This written into this particular format is invariant. Now I am showing it is also Lorentz invariant. Has to be. By using Lorentz transforms, this identity retains its form. I will say it is what? Lorentz. If any other transform, if I use the Galilean transform, are they invariant? Or any other transform I give you, if that form would have been retained, then I would have called it a general invariance. Good. So this is a qualification of transforms. I am using invariance by the help of Lorentz transforms. If I prove, if I show something is Lorentz invariant, there are 5 identities which are Lorentz invariant in physics, which is asked in the exam. What are they? This पहली तो यही है, x square plus y square plus z square plus z square minus c square t square is Lorentz invariant. They are Lorentz invariant. Then dx square plus dy square plus dz square minus c square dt square is also Lorentz invariant. This is called length element in theory of relativity. They are all Lorentz invariant. Then dx, dy, dz. Volume element is not Lorentz invariant. Dx, dy, dz will not turn out to be dx dash, dy dash, dz dash, but multiplied by dt. Volume element in theory of relativity is, it is a 4-dimensional space. dx, dy, dz, dt. It is also Lorentz invariant. तीसरा. Fourth. P square minus E square by C square is general invariant. This quantity P square minus E square by C square, I will demonstrate in some class after mass energy equivalence. This is equal to minus m0 square C square. This P square minus E square by C square is minus m0 square C square. M0 is the rest mass, which will be same in all frames. C is invariant in all frames. It is invariant. If it is this format, it is invariant. If by utilizing Lorentz transforms iso, P square means Px square, Py square, Pz square minus E square by C square. This is also Lorentz invariant. This is invariance. इसको क्या बोलूँगा भैया? Invariance. M0 is same in all the frames. C is also same in all the frames. Very definition it is invariant. But if I ask you so that this is Lorentz invariant, then you must know momentum energy transform. Then you have to open this is Px square plus Py square plus Pz square and minus E square by C square. Another frame Px dash square, Py dash square, Pz dash square minus E dash square by C square. So you must know momentum energy transforms. How momentum energy are transformed from one frame to other frame. Then we will prove this is also Lorentz invariant. पूरे कोर्स को एक बात में बता दे रहे हैं. Then fourth, fifth. This is called D'Alembert's operator. What is this called? D'Alembert's operator. It is del square minus 1 by C square del 2 upon del T2. Means this is del 2 by del x2 plus del 2 upon del y2 plus del 2 upon del z2 minus 1 by C square del 2 upon del T2. This is also Lorentz invariant. This is D'Alembert's operator. ये लिख दिया, इसका मतलब है this is. This will be same in other frame also. Del 2 upon del x dash 2, del 2 upon del y dash 2 plus del 2 upon del z dash 2 minus 1 by C square del 2 upon del t dash 2. 20 नंबर का क्वेश्चन पूछा हुआ है एग्जाम में. ये एग्जाम में पूछा गया है so that it is Lorentz invariant. Correct? So पहला बात बताना है कि what is invariance, what is Lorentz invariant. If any law or identity retains its form by using Lorentz transform from one inertial frame to other inertial frame, it is said to be Lorentz invariant. So first of all you have to write down what are Lorentz transforms. Then you have to evaluate right hand side must be equal to left hand side. ठीक है जी, पहला वाला करके दिखा रहे हैं, फिर दूसरा कर देते हैं, फिर उल्टा लटक जाओगे. x डैश स्क्वायर प्लस y डैश स्क्वायर प्लस z डैश स्क्वायर माइनस c स्क्वायर t डैश स्क्वायर, यह दिखाना है. करेक्ट. What is x dash? What is x dash? Alpha square x minus vt whole square. यही ट्रांसफॉर्म है. y dash is same as y square. Z square z dash is same as z minus c square t dash square क्या है? t minus vx by c square whole square and alpha square. करेक्ट. देखिए भैया अल्फा स्क्वायर आउट, इन दोनों में अल्फा स्क्वायर है. बाय द फर्स्ट टर्म x माइनस वी टी होल स्क्वायर माइनस सी स्क्वायर टी माइनस वी एक्स बाई सी स्क्वायर होल स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर. करेक्ट. जस्ट आई हैव कॉपीड, आई हैव यूज्ड द ट्रांसफॉर्म instead of writing 1 minus v square by c square all the time. In the last part I will write, you know that alpha. I am proving it is क्या Lorentz invariant because I have used Lorentz transforms. X dash is alpha x minus vt where alpha is root 1 minus v square by c square. T dash is t minus vx by c square into alpha. लिख दिया. v y square plus z square is out. लिख दिया इसको सब. अल्फा स्क्वायर इज आउट. देखिए भैया आंसर आ गया. एक्स स्क्वायर प्लस वी स्क्वायर टी स्क्वायर माइनस 2vxt माइनस ओपनिंग दिस सी स्क्वायर, ये हो गया टी स्क्वायर प्लस वी स्क्वायर एक्स स्क्वायर बाई सी 4. सो दिस बिकम्स माइनस वी स्क्वायर एक्स स्क्वायर बाई सी स्क्वायर माइनस 2vxt बाई सी स्क्वायर प्लस 2vxt प्लस वाई स्क्वायर प्लस जेड स्क्वायर. देखिए 2vxt कैंसिल्स आउट. इट इज अल्फा स्क्वायर. देखिए एक्स स्क्वायर माइनस वी स्क्वायर एक्स स्क्वायर बाई सी स्क्वायर क्या हो गया जी? 1 माइनस वी स्क्वायर बाई सी स्क्वायर एक्स स्क्वायर. दिस नाउ इट इज वी स्क्वायर टी स्क्वायर माइनस दिस. यहाँ पर मैंने माइनस सी स्क्वायर टी स्क्वायर आई हैव टेकन कॉमन. 1 माइनस हियर आई वांट वी स्क्वायर टी स्क्वायर क्या लिख दूँगी? 1 माइनस वी स्क्वायर बाई सी स्क्वायर, देखिए लिख दिया मैंने, विच इज नथिंग एल्फा स्क्वायर 1 माइनस वी स्क्वायर बाई सी स्क्वायर कॉमन, एक्स स्क्वायर माइनस सी स्क्वायर टी स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर। देखिए भैया, एल्फा स्क्वायर एंड 1 माइनस वी स्क्वायर बाई सी स्क्वायर कैंसिल्स आउट, विच इज नथिंग एक्स स्क्वायर प्लस वाई स्क्वायर प्लस जेड स्क्वायर माइनस सी स्क्वायर टी स्क्वायर। 5 बार एग्जाम में पूछा गया है, सो दैट इट इज लॉरेंज इनवेरिएंट। कैसे डिमॉन्स्ट्रेट किया? यूज द लॉरेंज ट्रांसफॉर्म्स, हैव डिमॉन्स्ट्रेटेड लॉरेंज इनवेरिएंट। फर्स्ट आई हैव एक्सप्लेन्ड। एग्जैक्टली सेम वे डिफरेंशिएट करेंगे, you will differentiate and you will show that dx dash square plus dy dash square plus dz dash square minus c square dt dash square is also invariant। अभी लिख देते हैं, डिफरेंशिएट भी कर देते हैं। करेक्ट हो गया जी। देखिए विद इन 1 पेज। dx dash square plus dy dash square plus dz dash square minus c square dt dash square, whatever is this। देखिए x dash was alpha, alpha is a pure constant, v is a constant, c is a alpha is a pure alpha x minus vt। dx dash क्या हो जाएगा भैया? what will be dx dash? alpha is pure constant, dx minus v dt, y dash is y, what is dy dash? dy dash is dy, z dash is z, what is dz dash? dz dash y dz, correct। t dash alpha out, t minus vx by c square, डिफरेंशिएट किया जी, dt dash alpha out dt minus vx by c, correct। स्क्वायर कर लीजिए, एग्जैक्टली सेम वे, जस्ट चेक, दिस विल बी लॉरेंज इनवेरिएंट। बट यू विल चेक बाय दिस वे, dx dy dz dt will not turn out to be dx dash dy dash dz dash dt dash। So one class I am telling you, just keep thinking and tell me tomorrow why। जब इनको स्क्वायर किया तो ds स्क्वायर, that is dx स्क्वायर प्लस dy स्क्वायर dz स्क्वायर माइनस c स्क्वायर dt dash स्क्वायर will turn out to be invariant। exactly same mathematics, same mathematics will yield invariant। स्क्वायर कर दीजिए, कोई बड़ी बात थोड़ा है, इसको स्क्वायर कर दीजिए, dx स्क्वायर dy स्क्वायर dz स्क्वायर माइनस c स्क्वायर dt डैश स्क्वायर से माइनस c स्क्वायर, इसका स्क्वायर कर दीजिए, ऐड कर लीजिए, ऐड कर लीजिए इसको, दिस इनवेरिएंट। बट दिस इज नॉट, अगर इनको मल्टीप्लाई करोगे, this may not turn out to be dx dash dy dash dz dash dt dash। it has to be, but mathematically if you will just blindly multiply, answer will not match। यहाँ पर मैच कर जाएगा। theoretically conceptual you have to think, then only you can argue out कि why dx dy dz dt is not same as dx dash dy dash dz dash dt dash। has to be, and already I said it is Lorentz invariant, has to be Lorentz invariant। but if simple multiplication of these four, dx dash dy dash dz dash dt dash is not same as dx dy dz dt, and it has to be invariant, it is invariant। समझ में आ गया भाई साहब, व्हाट इज लॉरेंज इनवेरिएंट? गुड इनफ। फर्स्ट कॉन्सिक्वेंस ऑफ दिस इज साइमल्टेनिटी। आई एम स्टार्टिंग विद साइमल्टेनिटी। साइमल्टेनिटी कैसे? साइमल्टेनिटी, व्हाट इज साइमल्टेनिटी? यहीं से शुरू करें. Two events which are simultaneous in one frame are not simultaneous in other, and vice versa. In theory of relativity, that means when the velocities are comparable with velocity of light, then two events which are simultaneous in one frame, they may be simultaneous in S or they may be in S dash. They will not appear to be simultaneous in other frame, and vice versa. Two events which are, very important fact, which are simultaneous in one inertial frame are not simultaneous in other. This has been also asked twice, in other and vice versa. Two events which are simultaneous in frame S, in one frame they are not simultaneous in other, and vice versa. This is simultaneity. In theory of relativity, the events which are simultaneous in one inertial frame, they do not appear to be simultaneous in other. Therefore, you have to be careful about doing the proper measurements. That is why the measurements are being done, and you have to be cautious in doing the measurements. Events which are simultaneous in one frame are not simultaneous in other. I am proving. What are simultaneous events? When I say events are simultaneous, same time. If this class is going on simultaneously at the same some other place, places may be different, but something is happening at the same time, then we say the events are simultaneous. Correct? Consequence of relativity is that in theory of relativity, space and time are interrelated. Whole velocity of light was absolute constant. Consequence of that was time in both the frames are different, and time is different due to space and time are interrelated. टाइम को कैसे ले, बीटा टी प्लस गामा एक्स. क्या किया टाइम को हमने, एक्स टी डैश वाज टी माइनस वी एक्स बाई सी. टाइम वाज डिपेंडेंट अपॉन एक्स. स्पेस एंड टाइम आर इंटर रिलेटेड. That consequence of this is simultaneity. Two events which are simultaneous in one frame are not simultaneous in other. So let us say events are simultaneous in yes. Proof. Vice versa also you can prove. Let events be simultaneous in frame. Yes. Then what do I mean? What is event? Event 1 is x1, y1, z1, t1. Frame was moving towards only x-axis, so there was no change in y and z. So basically event was x1 and t1. X and t. One event is x1, t1, other event is x2, t2 in frame S. पहले समझिए जी, frame S है. And there are two events. क्या? There are two events in frame S. Then I will view them in frame S dash or vice versa. So I am assuming that events are taking place in frame S, and because my frame was moving only towards x-axis, only coordinates which are important to me is x and t. So one event occurs at, one event is x1 at t1, other event is x2 at t2. Correct? Two events occur at frame S. They are simultaneous when t1 is equal to t2 and x1 is not equal to x2. That means x1 is not x2. बताइए भैया, x1 is not x2 but t1 is t2. ये तो दिया हुआ है हमें. Events are simultaneous in frame S. Simultaneous in frame S means they are occurring at the same time but at two different locations in frame S. Now I am going to view in the light of theory of relativity what they are going to happen in the frame S dash. So मुझे क्या चाहिए? I require t1 dash and t2 dash. I have to require t1 dash and t2 dash. They will be obtained from Lorentz transforms. So t1 क्या है बताओ? What is t1 dash? What is t1 dash? t1 T1 minus Vx1 by c square upon root 1 minus V square by c square. That is T1. Same event T1 measured in the frame S dash, it becomes T1 dash, it occurs at T1 dash is this. Now let us say same way, second frame, second event T2 dash, second event was T2 at x2, it is T2 dash, is T2 minus V by c square x2, बताइए, upon root 1 minus V square by c square. Good. From x1 T1 I have generated T1 and I have generated T2. Let us find out what is T2 dash minus T1 dash. वैसे भी लिख सकता था T1 was equal to T2, यहीं लिख सकता था. Subtract कर लेते हैं पहले. Subtracting, you have to demonstrate T2 dash is not same as T1 dash. They are not simultaneous in frame S dash means what? T2 dash is not same as T1 dash. ये तो demonstrate करना है ना. Events were simultaneous in frame S, that is T1 is equal to T2. I am going to put T1 is equal to T2, but x1 is not equal to x2. So I am just first taking the difference. T2 dash minus T1 dash is what? T2 minus T1. बताइए. T2 minus T1, the denominator is common. Minus V by C square, x2 minus x1 upon root 1 minus V square by C square. Simultaneous in frame S, that means this was 0. This V by C square x2 minus x1. x2 is not same as x1. This cannot be 0. बताइए, can it be 0? They were simultaneous. That means T1 was equal to T2. For the simultaneous event in frame S, T1 was equal to T2, but x1 is not equal to x2. Events were taking place at two different positions. Then only they were simultaneous event. It is not same. That means T2 dash is not equal to T1 dash and vice versa. Any doubt? कुछ पूछना तो पूछ लो. क्या? I have used the Lorentz transforms. I have measured x1 and t1 and x2 and t2. They are the measured coordinates. We have been given the event in frame S. Events were simultaneous in frame S. Simultaneous in frame S means x1, t1 and x2, t2 have been measured. Simultaneous in frame S. That means x1 and t1 has been measured and x2 and t2 has been measured. T1 is equal to t2, simultaneous. x1 is not equal to x2, it is known to you. I am going to check what is going to happen in frame S dash. That means I have to generate t1 dash and t2 dash. x1, t1 measured. I have to generate t1 dash. What I need to do? Lorentz transforms. Prove हो गया है. Vice versa can be also proved. That's what I said. Vice versa. Events which are simultaneous in frame S, they are not simultaneous in other, and vice versa. If I assume that events are simultaneous in frame S dash, that means what measurement is being done? Event is measured in frame S dash. x1 dash at t1 dash, x2 dash at t2 dash. They are simultaneous in frame S dash. That means t1 dash is equal to t2 dash, but x1 dash is not equal to x2 dash. They are measured coordinates. Now I want to see what happens in frame. Yes, तो क्या करोगे? Then you will invoke inverse Lorentz transforms. Event have been measured in frame S dash. Now I am going to write in frame S. तो क्या करते? तो उल्टा कर देते इसको. This is given. Simultaneous in S dash. In S dash, x1 dash is not equal to x2 dash. Correct? They are known. Given, known. That means not what I have to generate. I have to generate T1 and T2. For generating T1 and T2 and primes, have been measured, I have to go by inverse Lorentz transform. So T1 क्या हो जाएगा? T1 dash plus Vx dash upon C square. Vx1 dash upon C square. T2 is what? T2 dash plus V alpha B. T2 dash plus Vx2 dash upon C square alpha. देखिए जी, what is T2 minus T1 is alpha. T2 dash minus T1 dash is 0. Alpha V by C square. X2 dash minus X1 dash. This cannot be 0. That means T2 is not equal to T1. I have assumed that the events were simultaneous in frame as dash. They do not appear to be simultaneous in frame. Yes, that is very important in measurement. And answer that dx, dy, dz, dt are same as dx dash, dy dash, dz dash, dt dash. Has to deal with this simultaneity only. Two events which are simultaneous in one frame, they are not simultaneous in another. So you have to be very careful that the frame in which body is at rest, you are going to have the proper measurement. But the frame in which body is moving, you have to be careful while measurement. Correct? So, समझ नहीं आएगा? Try to understand. ये कर दिया मैंने. Now next, length contraction. Length contraction. Second consequence is length contraction, also called Lorentz-Fitzgerald contraction, because whatever Fitzgerald have predicted for the explanation of null results of Michelson-Morley experiment, that length is contracted by the factor of root 1 minus v square by c square. That thing is proved from your Lorentz transforms. But Lorentz transforms is having solid mathematical background. By rejecting the hypothesis of Michelson-Morley experiment, utilizing postulates of special theory of relativity, we have obtained Lorentz transform results. And utilizing Lorentz transform results, length contraction, same factor is same thing is proved whatever Fitzgerald said. So it is called Lorentz. This is also called Lorentz Fitzgerald contraction. Try to understand what is this. In simplest word, L, what is L? Automatically it will be written. L is L0 root 1 minus v square by c square. Every term has got their usual meaning and usual explanation. L is L0 root 1 minus v square by c square. It is called length contraction formula. देखिए, v is always less than c. v is always less than c. So L is less than L naught. यहाँ से clear है, L is less than L naught. What is L naught? What is L? What is L naught? If I put V0 here, in the same formula, if I put V0, if I put V0, velocity is 0, then L is L naught. That means L naught is what? That length when body is at rest. समझ में आ गया? इसी फार्मूले से मालूम पड़ गया what is L naught. L naught is the length when the body is at rest. This is called proper length. So proper length is measured when the body is at rest. L naught is called proper length. यही सोचना है. Proper length measured when body is at rest. What is L? L is the length when body is moving by velocity v. That is moving length. What is L? If the body starts moving by velocity v, then its length is L. L को कह दूं, L is the length with velocity v. Length is the length measured when body moves. When it moves by velocity v. ठीक है जी. When it moves by, so when it moves by velocity v, when it is at rest, then the length is maximum, L0. When it starts moving, length is contracted by the factor of root 1 minus v square by c square. Here it has to be, v was along what direction? V was along the direction of x. So this length is also along the direction of x, whatever the direction velocity is there. Good, whatever direction, if the velocity is towards x, then length along x direction will be contracted. Not along y direction, not along z direction. If the velocity of the body is having only one component, then length will be contracted along the direction of motion by the factor of root 1 minus v square by c square. Correct? If v is less than c, very less than c, no contraction. If v is very less than c, less than or 10 raised to power 6 bth, same, this factor becomes 1. L is same as L naught. When this operates, when it is operational, when v is comparable with velocity of light, comparable means 0.1 c, 0.2 c, 0.3 c, 0.4 c, that kind of velocities are there, then this factor will be acknowledged, will come into the play. If velocities are small, 10 raised to power 5 है, तो क्या फर्क पड़ता है? 10 raised to power 5 divided by 10 raised to power 8 whole square, that is 10 raised to power minus 6. 1 minus 10 raised to power minus 6 is same as 1. L is L naught. समझ में आ गया भाई साहब? So this thing, all the relativistic results are important when this factor root 1 minus v square by c square is significant. If this factor is not significant, it is not the domain of theory of relativity. This should be very clear to you from the beginning. So L is the proper length. L0 is called proper length. When it is measured, when the body is at rest. When the body is at rest, body is always at rest in its own frame. Good. So if the body starts moving, so whatever frame is attached with the moving body, in that body frame only body is at rest. If you are going on a train or traveling in a car or traveling in a space jet or space journey, then how you are going to measure the proper length? Proper length is to be measured when the body is at rest. Body where is at rest? Not in the lap earth frame. If you have gone to the space journey, then you are in the space, that journey. Then in that ship or that rocket, you are at rest. Not for the observer on earth. Earth observer, your distance will be reduced distance. That has to be very important. Good. Now how it is demonstrated? समझ में आ गया? What is length contraction? Experimentally demonstrated. It will be experimentally also will measure this. Lorentz Fitzgerald contraction. How the proof? This is frame S. I take a meter rod. This is frame S. This is frame S dash. This is frame S dash. Proper length is measured in which frame? In which body is at rest? This frame O dash was coinciding with frame O at t is equal to 0. Now this frame starts moving. That means this rod starts. This is a rod. Let us say meter rod. It starts moving by velocity v. This is the rod's frame. This is the rod's frame. So where the proper length is to be measured in frame S or S dash? S dash. So देखिए, अब यही समझना. So this end is. This end, this is my x1 dash, this end is your x2 dash, this is your L0, L0 is your x2 dash minus x1 dash. Try to understand and important. In its own frame, body is always at rest. So you can always measure any point of time you measure. There is no fight. You can measure both the ends simultaneously. Body is always at rest. In its own frame, moving frame, body is always at rest. So इसमें कोई fight है क्या? x2 dash, x1 dash. They are always measured simultaneously. Correct length is there. This is correct length, x2 dash minus x1 dash. Correct. And if this is simultaneous in one frame, they are not simultaneous in other. Try to appreciate. So where you have to be cautious in measurement. Caution yes में चाहिए मुझे. X in S you have to measure until unless you measure both the ends simultaneously. In frame S, you will not be able to record the correct length in frame S. Length in frame S is x2 minus x1, but for its measurement, correct measurement, x1 has to be measured at t, x2 has to be also measured at t. This has to be understood. यही समझदारी है, इसी में बहुत सारी चीजें होंगी. Otherwise there will be wrong. There is no point fight. Whatever way you measure in its own frame, always proper length will be recorded because both the ends are simultaneous. They are a body at rest. But in frame, yes, when I am going to measure this x1, measurement caution is that x1 is to be recorded at t, x2 has to be also recorded at t, then only I have to measure. So measurement has to be done of x1 at t and x2 at t. x1 dash and x2 dash I will generate. क्या measure करना है मुझे? I have to measure x1 at t and I have to measure x2 also at t. Until unless I measure both the variables simultaneously, correct length is not measured in moving frame. And S frame is a moving frame with respect to S dash. Correct? So I have to invoke Lorentz transforms. x1 dash generate कर दिया क्योंकि x1 I am measuring at t, x2 also I am measuring at t, so x1 dash आ गया. What is x1 dash? देखिए what is x1 dash? x1 dash is alpha x1 minus vt. I need not write all the time value of alpha, you know. And similarly x2 dash is alpha x2 minus vt. Both the ends are measured simultaneously. Correct? हो गया जी. So x2 dash minus x1 dash was the proper length is alpha x2 minus x1. I measured x1 at t, x2 at t. Anything else is fallacy. This is the only correct measurement. That simultaneously I am measuring both the ends. x1 at t, they are measured variables and they are predicted variables. From the Lorentz transforms, I am predicting x1 dash and x2 dash because they are, that is what I have to measure carefully. So कुछ नहीं है. x2, this is L naught. This is L naught. This is L upon root 1 minus v square by c square. L क्या आ गया जी? L turns out to be L0 root 1 minus v square by c square. Length contraction proved. कोई डाउट हो तो पूछ लीजिए. इसलिए यह ध्यान रखना है कि जब भी मैं dx वहाँ लिख रहा हूँ dx dash, whenever I am writing x dash is alpha x minus vt, I differentiate dx dash is alpha dx minus v dt. Whenever I am writing length element, it's okay. But when I write dx length, then it can be properly recorded only when dt is set to 0. तभी ये proper recorded होगा. तो इसको dt जब तक 0 नहीं करूँगा, then dx is not properly recorded. That measurement has to be Clapton in Colin Cope books. Clearly this thing has been given. Otherwise any other derivation, if you are doing from inverse Lorentz transform, it is fallacy. गलत है वो. क्योंकि here the crux is how you are going to do the measurement. यही crux है इसका, that x1 is to be measured at t, x2 has to be also measured at t, then only correct length will be measured in the frame. Yes, because simultaneously t does not hold good in both the frames. Whatever is simultaneous in one frame, it is not simultaneous in frame other frame. So in inertial frame, rest frame, body is always at simultaneous. There is no fight in measurement. So proper measurement has to be done in frame. Yes. समझ में आ गया भाई साहब? यहाँ से अभी प्रूफ भी हो जाएगा. ऐसे टाइम डायलेशन आई एम गोइंग टू डू. सो यहाँ dx dash would become simple alpha dx. dx dash will become alpha dx. Same way I am going to do in time dilation also. There is also crux of measurement. Time dilation. What is time dilation? Time dilation is dt dash is dt upon dt, or dt is dt dash या ऐसे समझ लीजिए t इज इक्वल टू t0, both the things are same, right opposite. T is t0 upon root 1 minus v square by c square. Good. This factor denominator is always more than 1. b by c is less than 1, so denominator is always more than 1. As a consequence, t is greater than t naught. t is greater than t naught. चाहे वो लिखूं चाहे ये लिखूं, दोनों एक ही बात है, टाइट ऑपोजिट. dt डैश को मैंने कह दिया t0. t0 is the proper time interval when dt dash measured in moving clock. Measured in moving clock. dt dash is measured when v is 0. dt is dt dash. dt is the time interval when it is moving by velocity v. dt is the time interval when it is moving by velocity v, which I am calling t. Moving time interval is increased, dilated. T naught is the proper time interval. T naught or dt dash, they are same. ये नो एक्सप्लेन कर दिया. दिस इज टाइम डायलेशन. t is greater than t naught. Moving time intervals are supposed to be dilated. They are increased by the factor of root 1 minus v square by c square. Also I can say moving clocks go slow. Moving clocks go slow. टाइम पीरियड बढ़ेगा तो ओमेगा घट जाएगा. मूविंग क्लॉक्स गो स्लो. दैट इज द स्टेटमेंट ऑफ टाइम डायलेशन. मूविंग टाइम इंटरवल इज मोर देन द रेस्ट प्रॉपर टाइम इंटरवल. टी इज ग्रेटर देन टी नॉट. एंड व्हेन दैट प्रॉपर टाइम इंटरवल इज मेजर्ड इन इट्स ओन फ्रेम, dt डैश. dt is dt dash 1 root 1 minus v square by c square. देखिए पहले ये समझ लीजिए. t is t naught upon root 1 minus v square by c square. Everything is clear. T naught is called proper time interval measured in clock's own frame. Clock's own frame. T is moving time interval. I will explain. समझ में आ गया. This is called time dilation. Moving time interval t is greater than t naught. यहाँ से आ गया t is greater than t naught. Clear है कि नहीं? t is greater than t naught. Moving time interval. How I am going to prove this? First of all, let me elaborate. Some astronaut goes on the space journey and he measured time that he returns after spending 1 year in space. Astronaut returns after spending 1 year. He says that he has returned after spending 1 year. And there is another person in the earth. The person who is on earth, he says that 17, the other person has gone and he has spent 1 year. If he has gone by some velocity, time interval has been dilated. Good. So he says, the person who is on earth, he says that person who has gone on the journey, his time period has been dilated. That to say, I can express in another way also. Twins paradox. There are two twins. Twins means their ages are same. One of the twins goes to the space journey and returns after 1 year. And the twin which returns after 1 year, he says that adult twin has grown older. Good. Calculate. Let us say travels by the speed of 0.998 c. T naught is 1 year and V I am telling you 0.998 c. What is this factor? 1 by root 0.998 whole square. Tell me what is this? Huh? 1 by point, so how much is 1 by 0.063? 100 से डिवाइड कर लो कितना, 100 by 6 कितना, 16 years, 17 years. This turns out to be 17, correct? So if T0 is 1, T0 is 1, T will turn out to be 17 years. Good. So if both the person's age were same, they were 20 years at the time of departure. The person who comes after 1 year, he says that the twin on the earth has grown 37 years. The person who returns after 1 year, he finds that the twin on earth has grown 37 years. That is the statement of the person who has gone and returned after 1 year. Similar statement is made by the other person also, twin on the earth. If he measures 1 year, the twin on the earth, he says 1 year. So I am 21 years old. Other person has gone on the space journey, so he has become he has gone by this velocity. He has become 17 years older, that he has become 37. This is the paradox. Both of them say that other person has grown older by 17 years if they are traveling by this velocity. How to resolve? पहले समझ में आया what is twins paradox? What is paradox? Paradox is that both of them say that if they say that 1 year according to my clock it has elapsed, according to other person's clock, because that is a moving time interval, I am measuring the proper time. Earth twin says that I am at rest, other person has gone on the space journey, he is a moving twin, relativity works, this formula works. So his period is 1 year. Twin on the earth says that according to me it is 1 year. मैं तो यहीं रह गया 1 साल, ये 17, इसका 17 साल हो गया. If the twin measures on the earth, twin measures 1 year, and he says that the other has gone older by 17 years, 37 years. Similar way, if the twin who has gone on the journey, he returns after 1 year, he says that I was rest in my frame. This person is a moving frame for me. He has grown older by 37 years. 17 years बढ़ गया, 37 हो गया. Both of them are claiming, if they measure one year in their intervals, both of them are claiming that others have gone older. But what is the fact? How there cannot be any confusion in relativity. Relativity is very clear. That has to be understood. Who is the proper frame? The person who is on the earth, he is claiming 1 year. Who is the proper frame? Proper frame is that where the body is at rest. Where the body is at rest? The person who has gone on the space journey. So if the twin on his space journey says 1 year has elapsed, that is the proper time for him. Proper time can always be measured by the body, by the twin who has gone on the journey. Good. So space journey twin, if he says 1 year, that is T0. And for the twin on earth, this is 17 years. So twin on earth has really become 37 years old. Good. Now when he says that if earth twin says I am 1 year, basically that is 1 by 17 years. Time period of twin on earth is 1 by 17 years. That will be reduced period. Experimentally proved also. The twin who goes on the space journey, his biological clocks, metabolism is also slowed down. Twin on the earth, proper time interval is always measured when the body is at rest. So according to physical measurement, proper time cannot be measured by the twin which is on the lab. Lab twin is not going anywhere. He cannot measure the proper time interval. Proper time interval will be measured only by the body which is moving. Moving body means space journey. So if he says that he has spent 1 year, then he is really 1 year. So 21, he is 21, and the person on the earth has become 37 years old. Good. Now, vice versa, the claim of the person on the twin on the earth, he says that I have spent 1 year. If he has spent 1 year, the person on the space journey has 1 by 17 year only. If his measurement is 1 year, earth, then Space journey is 1/17 years. Because time dilation works only in the Earth's frame of reference. Proper times are always measured in the body's own frame of reference. वही crux है इसमें. That is why T naught proper time interval is measured in clock's own frame. Good. So try to appreciate. This is S dash. S dash is moving by velocity v. This is clock. This is clock. This is clock. Proper time interval is to be measured by here only. Proper time interval is to be measured only by this. Correct? Try to understand this. T naught has to be T2 dash minus T1 dash is the interval. 1 घंटे का interval है. Clock is hit at 10 o'clock, then 11 o'clock, then is 1 hour period. Good. But crux of the measurement is that this clock should not move. Time interval has to be recorded at the same place. समझ रहे हैं? I am measuring 1 hour. ये थोड़ा है कि यहाँ से क्लास शुरू किया, दूसरा घंटा मेरा कहीं और बेंगलोर में बज रहा है, जाके न्यूयॉर्क में बज रहा है. Not at all. Both the places that T1 dash is to be also measured at x1 dash. T2 dash is to be also measured at x2 dash. By keeping the clock fixed, then only correct time interval will be measured, because simultaneity, what is the simultaneous in one frame or not simultaneous in frame? Yes dash. Correct. So if I have to measure the, first of all, time interval is to be measured in moving frame. V is to be set to 0 in its own frame. And T1 dash is to be measured at x dash. T2 dash has to be also measured at x dash. Then only proper time interval will be measured. So crux से क्या measure कर रहे हैं? T1 dash and T2 dash at x dash. Otherwise, I am not able to measure T0 properly. This is the palace. This is the main thing. So T1 dash at x dash, T2 dash at also x dash. This is to be measured. Correct? ये measure करने हैं. दूसरे frame में मुझे generate करना है. क्या करना पड़ेगा मुझे? What I need to do? Inverse Lorentz transform, because now I am measuring T1 dash at x dash, T2 dash at, they are measured quantities. I have to generate T1 and T2. T1 and T2 I can generate from inverse Lorentz transform. This is the crux of the measurement. This is the crux of measurement. Crux of measurement lies in recording the proper time interval. Proper time interval has to be recorded in moving frame and keeping the clock fixed. This means keeping the clock fixed. Not that T1 dash I am measuring at some x1 dash, T2 dash I am already measuring at some x2 dash. Both of them keeping the clock fixed. They are measured quantity. Others I am generating. So देखिए भैया, T1 is nothing alpha T1 dash plus Vx dash by c square. T2 is alpha T2 dash. समझ में आ भैया? T1 is alpha. ये मेजर कर दिया T1 dash at x dash, T2 dash also at x dash. T1 and T2 I have generated. So I am measuring the interval in frame, yes. I am measuring the interval in frame, yes. Inverse Lorentz transform I have invoked. Time dilation is proved invoking inverse Lorentz transform. That is proved. Length contraction is proved invoking the Lorentz transforms, because there the crux was correct length was always measured in moving frame. You have to measure x at t, x1 at t and x2 at t. That was the correct. Here this has to be measured itself is a crux. So now T2 minus T1, देखिए जी, T2 minus T1 is alpha T2 dash minus T1 dash. dt is dt dash upon root 1 minus v square by c square. The moving time, the proper time. This is t. This is t naught. Root 1 minus v square by c square. That is how the time dilation is understood. समझ में आ गया भाई साहब? How time Twins paradox is clear. What is Twins paradox? They are all detected. T1 is this. That is how they are proved. ठीक है जी। तो अब देखो जी, अगर मुझे ये प्रूव करना है dx dy dz dt is invariant, so you have to prove this dx dash dy dash dz dash dt dash is Lorentz invariant, that you have to prove this, correct? Y is y dash, z is z dash, so there is no change because frame of reference was only moving towards x axis. So y is y dash, z is z dash, dy is dy dash, dz is dz dash. So ultimately you have to prove that dx dt is dx dash dt dash. डिफरेंशिएट करके नहीं आ रहा था, देखो वैसे तो एक लाइन में आ गया, बता देता हूँ. लेंथ इज कॉन्टेक्टेड, टाइम इज डायलेटेड. लेंथ इज कॉन्टेक्टेड, टाइम इज डायलेटेड. हम कहीं से भी लिख दे, किसी से भी शुरू कर लें. पहले आर से शुरू कर रहे हैं. dx dash प्रॉपर लेंथ, dx dash इज द प्रॉपर लेंथ. सो मूविंग लेंथ कितनी हो जाएगी, dx क्या हो जाएगी, dx रूट 1 माइनस वी स्क्वायर बाई सी स्क्वायर. dx dash क्या होगा, dx उल्टा उल्टा उल्टा, हाँ बाई 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 ना, नहीं dx dash क्या था, ये था ना, एल वाज जस्ट होल्ड ऑन, एल वाज और एल नॉट रूट 1 माइनस वी स्क्वायर बाई सी स्क्वायर. सो एल नॉट इज एल बाई उल्टा. dx dash is your dx upon root 1 minus v square by c square. dx dash is the proper length. I want to write in terms of moving length. So it is dx upon root 1 minus v square by c square. What is dt dash? Proper time. It is what? ये था मेरे पास, t was t naught upon root 1 minus v square by c square. So t naught is what? t into this root 1 minus v square c square dt. Length is contracted, time is dilated. dx dt is nothing, dx dash dt dash is same as dx dt. I have started the dx dash dt dash is same as dx dt. Prove हो गया. Length is contracted, time is dilated. यही होना, that is what theoretically has to take place, correct? But if you multiply by differentiation, you will not be able to do. X dash was alpha x minus vt, dx dash was alpha dx minus v dt, dt dash was alpha dt minus v by c square dx. Multiply करो, आ रहा है क्या, नहीं आ रहा है. If you multiply dx dash dt dash, it turns out to be alpha square dx. This is, you will not get. करेक्ट, ठीक है ना. मल्टीप्लाई का डिफरेंशिएट कर दिया तो नहीं आया. मैथमेटिक्स हैज गॉट लिमिटेशन, प्रॉपर्ली अंडरस्टूड, एवरीथिंग हैज टू बी प्रॉपर्ली अंडरस्टूड. इसका जब मेजर कर रहे हैं dx dash, then caution is that dx has to be measured. dx dash is always properly measured. You are using the Lorentz transform. dx dash is always properly measured, but dx has to be measured only when dt is kept 0. dx will be measured, length will be proper, length will be measured in frame S only by keeping dt 0. ये आ गया dx dash is alpha dx. यहाँ ये रखा तभी मेजर होगी लेंथ. You are measuring length interval, dx can be only measured. dx dash no problem, but is always at rest. Any point of time you measure, both the ends will be simultaneously measured. In frame yes only problem. So dx has to be only measured by dt. This is correct. But ये तो फार्मूला ही नहीं लगेगा, क्योंकि इनवर्स, here I have to bring the inverse Lorentz transform. समझ रहे हैं जी? Now you write dt is alpha dt dash plus v by c square dx dash. Here crux is that dt dash is measured by keeping dx dash 0. Hello, dt is your alpha, dt is your alpha dt dash. तो dt dash क्या हो गया जी, dt by alpha. Multiply, follow. That is how you have to be cautious about how the proper measurement is to be done, and these things are very nicely explained in the book of Kleppner and Kollinkopf. Whenever you will read the chapter of special theory of relativity, only Kleppner and Kollinkopf this makes this measurement thing very clear. Otherwise, any other thing is wrong. So that is why the way twins paradox was also resolved in the same way, that whose measurement is correct? The person who has gone on the space journey. Then explanation is also there, that the person who goes on the space journey, that is the proper interval. In Earth's frame, that is dilated time interval. That means the twin on the Earth will grow older by 17 years. Because the person who goes on the journey, space journey, his biological clocks are slowed down. There is no gravity. They are floating. So, graying, aging takes place on Earth. Aging does not take place on the planet where the velocity is 0.998 c. So, that is how the proper time measurements are always done in the frame of references attached with the body. Correct? समझ में आ गया? ये समझ में आ गया? Numerical सारे खत्म हो जाएंगे. Nothing, there is nothing in the numerical problem. Only पहले see here was how you are going for. Otherwise, you couldn't have even demonstrated that length interval, volume element in theory of relativity is invariant. Dx, dy, dz, dt, dx dash, dy dash, dz dash, dt dash. Multiplication will not yield you the result. Only proper understanding has to be done. Good. Class is concluded. We will meet tomorrow, same time, same place. 3 topics I have done. Length contraction, time dilation, simultaneity. Now remaining 4 I will do in tomorrow's class, and half of the seat will get over. Then we will move to something else. Thank you.